Hi, my name is Frauke Kreuter. I'm from the Joint Program in Survey Methodology at the University of Maryland. And I'm talking to you today as prior co-chair of the AAPOR task force on big data, and provide basically an oral version of the big data task force report that we wrote talking about big data in survey research and official statistics. When I say we, I mean Lily Japek, the co-chair. He's at Statistics Sweden. Markus Berg, student with her at Stockholm University. Paul Beamer from the Research Triangle Institute, RTI International. Paul Decker from Mathematical Policy Research. Cliff Lempe, School of Information Science at the University of Michigan. Julia Lane at New York University with the Wagner School and CUSP. Casey O'Neill, Johnson Research Labs, and Abe Usher from Human Geo. We have last year in February presented this Big Data Task Force report to the AAPOR Council, and then subsequently held a session at the last AAPOR conference. And some of you might have seen the written version of this task force report at the POQ website, where you can also read the full version. Nevertheless, a webinar can be nice, and hearing an oral presentation might fill in some other gaps or emphasize and focus in a slightly different way. So hope you'll enjoy this recording. As you know, our association is an organization that's dedicated to advancing the study of public opinion. And if you look at the AAPOR mission, you see that this is broadly defined and includes attitudes, norms, values, and behaviors. And that's certainly something to keep in mind when we talk about big data, because many of the applications are in fact on measuring behaviors, and maybe much less measuring attitude and norms and values as we would do through surveys. We also have in our statutes the notion of promoting best practices and promoting transparency. And in this new era of big data, both of these pieces certainly need a lot of attention, because best practices are often not known yet, and transparency is often lacking. So I do want to make these 2 points as precursor. In what you see coming here, those are unsolved issues still, even it's only a year after we presented this, but obviously while a lot has happened, not that much in those two areas. And then finally, a mission of AAPOR is to educate its members, and so we'll have educational suggestions in this presentation and in the report, and I will report about some new educational developments in the field that weren't around at the time of, or just started at the time of the task force report, and could be interesting for you to look up. All the task force reports on other topics as well are available on the AAPOR website, www.aapor.org. The report itself has 4 objectives: to educate AAPOR members about big data, to describe the big data potential, to describe the big data challenges, and to discuss possible solutions and research needs. That's when you read the entire report as it is printed and put up on the AAPOR website. In this talk, I'll highlight a few of these pieces. I will talk about what we define, or how we define big data in this report. I will highlight the paradigm shift that researchers see happening with the advent of big data for social science. And I will highlight big data activities in different organizations, challenging our research, but also showcasing what to look for in terms of process and data quality. And then, as I indicated before, we will look at skills required and examples of education initiatives. So let me start with the task force report and sort of remind everybody on where we started here. Most of what we've done in the past until recently is related to three main data sources: surveys, data from experiments, and data from administrative sources. The latter actually is in part what has been discussed as a big data source, in part because it's data that are generated as a byproduct of other processes, and they can sort of be found in the same way as other big data can be found. And I will come back to this differentiation of found and designed data, but just to throw this out here, the first two, traditionally we would carefully design in form of a questionnaire, in form of an experimental design, in form of a sampling scheme, and the like. What's new nowadays is that we have other data sources that come in often at a rapid speed. So before we talk about definitions of big data, a few examples for you. The first one coming from the PriceStat website. This is what you see here on this graph is the U.S. official CPI, and in blue, and in orange you see an PriceStat index, both trying to reflect aggregated inflation series on a monthly basis, starting in 2008 and ending at the end of 2014. And so, we took this right before the report was finalized in January of 2015, and this is the same graph. Nowadays, of course, you could get this updated, including all of last year. What is interesting is that these two series follow each other pretty closely. And what is interesting is that they use completely different methods to generate the data behind, or generate these two statistics that trail each other quite well. So what are those data that they used? The PriceStat folks, they scrape web pages. That is, they take, or actually initially they scrape web pages, I shall say, which means they take information that's posted on a website and let's say a price of a computer or the price of a book, things that you can shop online, and do this repeatedly and monitor sort of changes in prices over time. Turns out that that's actually pretty laborious, and that holders of websites don't necessarily like this form of data collection of their websites. And so what PriceStat did actually is with many online vendors to have agreements that either they approach the website at certain points in time or that they just get their data. But this aside, it's an online price index, so it's data from online sources. But it works pretty well to reflect what the CPI puts out. Now, granted, CPI data are used to, quote-unquote, train these data, a term that I will come back to. Another example is from Statistics Netherlands. What you see in this graph are the number of vehicles detected in the Netherlands on December 1st in 2011. And the vehicle size is shown in different colors. Black is small size, red is medium size, and green is large size. This is over the course of a day. These data come from sensors. So the first one came from web traffic or web postings, and it was taken off there. This one here is sensors that you put in streets or cameras that you can put top of a street and the like. So another source of big data that is frequently arising. And then the third one, also data from the third example here, also data from Statistics Netherlands. They use social media sites to create a social media sentiment index. And what you see here is a consumer confidence index. In the larger graph, that's the index that's taken from social media sites using text analysis techniques. Details can be read up in Dallas and Putz 2014. You see the whole list of references, by the way, in the AAPOR task force report. And then in the upper right corner, you see the consumer confidence over the same period of time conducted by a survey. So again, similar patterns for these two measures. Now that we've seen these examples, let me come to sort of a general definition of big data, and you will see that all of these examples fit sort of nicely into that definition. You often see definitions of articles of big data starting with, the 3 V's, sometimes 4 V's, increasingly even more words that start with the letter V. But the 3 that you most often see are volume, velocity, and variety. The first one relating to the sheer size of the data. And, terabytes might not longer cut it as being called big data. Cliff Lampy, one of our task force members, he kept saying, well, for him, big is when it doesn't fit on your computer anymore. Obviously, that already reflects how relative this term is, and as computing technology advances, big might not be the same in a couple of years from now. So don't get hung up on the actual size. It just means large volume, and maybe volume larger than what you or your computer normally can handle, or what you've done in the past. But you will quickly see that volume is actually not the most interesting feature of big data, which is interesting because that's what the name seems to indicate, right? All right, so the second one is data in motion. Many of these big data sources, they come in at a high frequency or higher frequency than we are used to. So you can see, price changes, unlike in a survey when you say, okay, we can go out and we scan a set of stores or other places, that we identified in our sampling scheme ahead of time, or we interview people about their labor market status and the like. That would be usually one point in time, and maybe every 6 months or every 3 months, but not continuously. And many of these big data that we talk about or you see used, and that are certainly interesting for exactly that reason, is that data comes in all the time. Think of Twitter. You see notices coming in all the time. Sensor data, obviously, every time a car goes through, you would get information from that. So that's what's behind this velocity statement. Variety is related to the fact that many of these big data sets are unstructured and include a variety of different data formats. This can be text, this can be video, this can be voice, numbers, letters, anything. And actually, we've seen this in surveys too, right? I mean, you have, often free text, or you might even have a recording of an interview. People might have taken measurements of sorts, but the difference is that in a survey, we would take these measures and the interviewer would usually convert them into numeric values right away, coding this on the fly. But increasingly not so much, right? I mean, we have plenty of surveys in government statistics or social sciences that take, let's say, blood samples or saliva samples, and they certainly are data that come in different forms as well. So, nothing entirely new, but maybe here too, it's just the volume and the variety, the size of this that is changing. And then lastly, luckily, increasingly mentioned when we talk about big data is this issue of veracity. The fact that big data also have sometimes doubtful characteristics, if you will. They're inconsistencies, they're missing data, they're ambiguities. data might not always be what you think they are. They are, better for certain objects and units of observation and than others. Just think of if pictures are part of the data, right? Lighting might affect the quality of the picture and the like. So there's certainly a variety in the veracity, if you will, in the quality of the data. So these characteristics often, are used to describe big data. But what is, in addition to this classification, very helpful in thinking about what do we count, or do people count as big data, is this notion of where do the data originate from? What's the data generating process? And so, those of you who have followed Bob Gross on when he was Census Bureau Director on his census blog or talks he's given, you might have seen him mention the terms designed and organic. And Mick Cooper also talked about these two terms in his keynote. Now it's, I guess, 3 years ago that he gave at the Ezra conference and was subsequently written up in Survey Research Methods. This notion of designed and organic was picked up by Roberto Rigon-Bon, who is part of this Price-Stud group at MIT that I showed you graphs before. And he made this little chart for a conference that was held at the Bureau of Economic Analysis that I thought was quite useful and wanted to share with you here. He took this differentiation, designed and organic, and then classified sort of the different types of data that are either designed or arise organically, with experiments and surveys clearly being data that have been carefully designed and then collected. Administrative data falling somewhat in between these two. As we said, they arise organically as part of a process, but nevertheless, someone was there and designed, a form that you have to fill out when you file your taxes, or a form that has to be, put into place when you apply for Social Security benefits or what have you. In the organic classification would be data that Roberto classified as aspirational. Here Mendo referred to anything, on, for example, social media, Twitter, where people sort of report about themselves in whatever way they want, and at whichever interval length and frequency that they want. And then transactional data, which is less about people's statements and, sometimes maybe, I wouldn't say wrong, but biased statements about themselves, to pure sort of transaction of, for example, credit card purchases or other things that sort of happen as a byproduct of human behavior. Cliff Lampe, actually, he didn't favor so much in our discussions this term organic data, but replaced it with the term found data, which I also like because it basically means that there's a chance to come across these data and make use of them. And that's exactly where the hope comes from, right? So we invest a lot of time and money to collect data by design, or to design data collections to begin with. And increasingly, people recognize that data can be found some other place and may be used in addition. And so the hope around these found and organic data is that they can replace or augment expensive data collections. And because there are more data overall, the hope is that this will lead to better decision making. And the other hope is that information can be made available in nearly real time. Think of last time you visited a website like Amazon or Netflix or any purchasing website that tends to suggest other things that you could be interested in based on past behavior. Obviously, these kind of things should happen pretty quickly and should be up to date to be most effective. Now, this notion of having more data, maybe cheaper, and I say maybe because we will see when we talk about skill sets later on that in part this could just be a shift on where the costs arise, whether it's in the process of data collection or in the analysis and preparation stage. But sort of this shift to where the data arise and how much money you have to put up to get them, paired with the fact that you have more fine-grained data on maybe more units or more time points, allows for new kinds of discoveries because you have, new units of analysis altogether and more fine-grained analysis options. So Lee and Gilles has put out this paradigm shift, from observational scientists to analytic science via computational science to data exploration. And you see big in the debate, the notion that just by having the data and looking at the data, new insights can be found. I'm maybe too much of a traditionalist to entirely buy into that. I think discoveries are still made or are still driven by research questions and the fact that people do have an interest and then look at specific things and choose to look at specific things and not at others, and that hasn't changed. But what certainly has changed is that we can, instead of sort of being limited in the kind of questions we ask by the data that are available, so, what research question can I answer with the PSID, to, looking at the research question and maybe dream up some data that might be available to help you answer that particular research question. Another paradigm shift that we discuss in the report is that this difference in cost structure means that many more people have access to data and can be sort of, what a term, you will find in various places, be a citizen scientist, right? So the open data movement with a lot of cities or governments putting out their process data, organic data for analysis allows, anyone to go online, assuming they have the skills to analyze data, to actually, create, generate some insights of these data. Now, how good these insights are and how valid they are beyond, the actual data set, that's a different story, but we always had that, so that's no news here. In terms of unit of analysis, if you need some examples to think about that, networks certainly are a completely new unit of analysis that can be observed much better than they could have been in the past. Because of this hope and this notion that entirely new sets of people might contribute to what we need, you see movements in the social science world and official statistics trying to make use of this. So in January of this year, Eurostat had put out a big data competition, hoping that they could entice people to come up with alternative indicators for unemployment, for tourism and retail trade, and some other economic indicators they are interested in. And the goal being like, okay, find some data out there and have an idea if those could be leading indicators or help replace or augment existing indicators. And the EU is just one place where this discussion happens. In the US, the federal statistical agencies are looking at this as well, and likewise on the United Nations level, we see big data initiatives coming up all over the place. And the UNECE, they started a sandbox that provides computing environments to load big data sets and tools to explore, things like the consumer price index, mobile telephone data, smart meters, traffic loops, social media, job portals, web scraping, and the like. So if you get interested in looking at this, go to these various websites and take a look. It's pointless for us to give examples here, because this field is developing so fast that whatever we do or would do here would be outdated immediately. So go explore for yourself, and if you stop listening to this recording because of that, I will not be offended. Now, one thing that's pretty cool is, in this context of the open data movement and data.gov in the US, but other countries also moving in this direction, making these found data available to actually be found and used, there's one keyword that you will see come up and be useful. Often you might be referred to what is called an API. API application programming interface, is an application programming interface. It's basically a software tool designed to help communications between software, different types or platforms. And in the web context, you might have come across the keywords of HTTP protocols or XML or JSON. All of these are sort of formats for data and information exchange. So basically, you put a request to a website, and you get some answer back, and in some format. And with this API, think of it as a gas station for data, if you will. You can visit government websites, company websites. You can, whether it's Yelp or the White House, doesn't matter. They all now allow you to access data directly from them using these APIs. If you have time on your hands, I recommend going to data.gov and just checking out how you can get access to the data from the American Community Survey using their API. What you will see there is a website that roughly looks like this. It's not too difficult to do that, and you will find, if you dig deep enough, that most of your statistical packages that you use have nowadays some input format to read in these JSON files. That's just one file type, just in the same way as you learn to read in SPSS, SAS, or other system files. This is just one more. So far we discussed what are these new types of data, what are people trying to do with it, and where do they come from. Right? Now, as we move forward as a community, it is important that we do some research here. I mean, after all, AAPOR has been, at the forefront for decades to do research into the generation of survey data, meaning looking carefully at survey quality, at the process of data generation as form of a survey, including sampling errors, errors of response or non-response for that matter, errors that come through weighting, adjustment, or the removal of errors through that, errors in coverage on the sampling frame, errors in measurement, errors in conceptualization, and the like. The same kind of research will be needed going forward when looking at big data. And as part of the task force, Paul Beamer created this nice little map to visualize the big data process, or the data generating process. And we just talked about the various sources that data might come from. So you have data from sensors, data from cell phones, data from Twitter, data from credit card records, what have you. From each source, you would go ahead and first extract the data, then transform them, meaning cleanse the records. There can be all kinds of I'll speak about the errors in a moment. So cleansing, transforming is the second step. Then you would load the data into some database management system and start analyzing the data. In this step, often you have a sampling piece, which actually makes our profession even more needed than ever, because many more people actually have sampling challenges than they had in the past. But also, there's a big step here on either at the very end when you start reducing the vast amount of information, and you basically decide on creating filters and rules on which are the cases you want to analyze, but also prior in the transformation step, you generate often new variables, which the computer scientists call feature generation, right? So characteristics of a unit of observation that you decide could be interesting to analyze. So, let's say you take sensor data and between 2 points in time that a car drove over, a new feature that you would generate from that is the speed with which the car was traveling. It's nothing that you measure immediately, but if you have 2 measurement time points and know what's the distance between these two, then you can generate that feature. So that would be one example for it. Now, those of you that have been in the survey profession for a while can immediately start thinking about errors related to this process, right? So in the data generating process, or right at the beginning, at the source, you can have a lot of errors included there already. You might have a low signal-to-noise ratio. You might have lost signals that transmission was interrupted, or failures to capture in the first place. So if you measure step counts, right? These days, lots of people have some measurement device on them that counts their activities. If they run out of battery, if you fail to put them on, you won't have data captured that way. They've never entered the system. You would have, non-random representation of the sources. Not everyone is on Twitter, not everyone is on Facebook. So the sheer masses of people on these certainly don't guarantee full coverage. Often we don't have metadata, so we don't know exactly what each of the variables really mean and how they have been constructed. And likewise, they can be just errors of any kind in the data source at the beginning. It's hard to say that in general because it very much depends on the individual data source, which is, again, great news for our profession because we have been in the business of detecting and thinking about these errors for a long time, and so lots of research and work opportunities here. But also at the ETL step, there are errors that we need to consider. You might have specification errors, meaning that what you try to measure doesn't necessarily fit what is in your data. You might combine data from different sources and have errors in that matching process of linking records to each other. You might have coding errors when you transform the data, or editing error. Often these are referred to as data munging and data integration errors. And then in the analysis step, you also have errors, some of them very familiar to us, sampling errors. We know quite well how that works. But then also, selectivity errors, modeling errors, depending on what you do in the post-processing of the data. And then, that goes all the way to the actual analysis and output. There might be algorithmic errors for when you do heavy computation with them. You might apply inadequate models to your data, just like, issues that we always dealt with with more traditional data sources. So this is one big area of research. And on the last two, actually, a lot of work has been done, right? Because we know that computer scientists in other fields and researchers in other fields have been working on these techniques to quickly analyze and process large amount of data for quite a while. I mean, just think of all the astronomers that survey the sky for quite a while and deal with massive amounts of data, or the geographers who have been dealing with massive amount of data for quite some time to predict earthquakes and the like. So there's a lot of progress that has been made. But on these other areas, sort of looking at who is represented, what should really be the unit of analysis, how do we extract, how do we transform, how do we specify what we want to measure, that it's much less explored because that depends so much more on the specific data source and your research question that you're trying to address. Now, another field of research, and actually a very interesting area to think about, is this whole area of access and linkage. In many settings, the found or organic data are described or can be characterized as being rich in observations but variable poor. So you might have only a few variables, let's say transaction data. That's a lot of data, credit card records and whatnot, but you might know anything about the actual person behind it. And so ideally you would want to link those data to other data sources, and in particular if you think administrative data, they have good information on all the data that are relevant for a particular program that is administered, but maybe not so good information on anything else there. In part because whoever fills in these forms as part of the administrative process, they would make sure that the variables that are important, let's say important to get your pension or your Social Security benefits, so variables on income will be of very good quality. But maybe variables on educational level or your nationality are much less important, and therefore could have more missing data or even be erroneous. So the goal would be to link different data sources that have different pieces of information and good quality across the different sources. But these linkages are challenged by different privacy requirements, different regulations in various constituencies of agencies or countries or whoever generates the data to begin with. So that's a challenging and interesting area right now. There are a lot of open issues on ownership. There's a lack of trusted third parties that the data can be turned over to where linkage happens, although there are interesting developments going on there. Julia Lane, one of our task force members, is working on a big project at NYU to create such center, for example. There's also an ill-defined legal space, and I'll say a few more words to that in a moment. And all of this just goes to show that certainly these issues of transparency in the process of putting these data sets together is quite important and will be even more important coming up. You already probably had your eye on this picture here in this slide. This is the cover of an edited volume that Julia Lane, Victoria Stodden, Stefan Bender, and Helen Nissenbaum put together for Privacy, Big Data, and the Public Good. I can highly recommend this book. It does address a few interesting questions that the task force report only touches on because we knew this book is out and things can be read there in more detail. But the core questions that are sort of covered there and touched upon in the AAPOR report on big data are issues of what is the legal framework that can or should be used here, what is the practical framework, and what is the statistical framework. And on that legal framework, the big takeaway point so far, or still, is that the current legal structure is inadequate, right? So in the current, well, as Strandberg put it, the recording, aggregation, and organization of information into a form that can be used for data mining, here datafication, has distinct privacy implications that often go unrecognized by current law. And that is true for a lot of countries. Now, since then, a lot of things have happened, and again, the European Union pushing quite heavily this field. But in general, we don't have a good assessment of harm for privacy. We have, past rules like informed consent that in this new world will likely not longer be possible. And likewise, it will hardly be possible to assure anonymity. And in short, researchers, or many researchers in this field, would say that privacy and big data are incompatible. Now, just to give, one example here, why is this sort of difficult, right? You might have seen that, there were a lot of speculations after the marathon in Boston, and, people being accused, and, with very bad outcomes to such accusations here. That certainly is something that, can happen easily with data and, being available, such as video streams and, people picking up images and maybe wrongly classifying them and the like. So here's a risk that certainly cuts way deep into privacy issues. But also in the survey context, right, we are sort of used to safeguard ourselves with informed consent. And, in the big data world, this is much, much less possible, because, how many of you have a smartphone with apps on it, and have you read all the legal terms that are in there before you consented? Probably not, right? So giving notice and then having a choice, these concepts don't quite work in the same way anymore. We can't assume that people really process and understand what they agree to. But also, it is not feasible, because sometimes you wouldn't know upfront what the data will be used for afterwards. And then it would be very difficult to go back and ask for consent for these, individual new requests. And it's just not reasonable to require this burden on, understanding this from the respondent or from whomever data would be collected, or from organizations that try to do business on a very different purpose, or let these be agencies, not just private sector companies. So that can't be the solution here. Plus, even if you don't agree, let's say we would have this, there might be friends in the Facebook sense that reveal information about you that you have no control over, or you have, on certain issues, everybody being involved, and the fact that you decide not to be part of it already makes you suspicious, which, can be sort of subsumed under this keyword of tyranny of the minority. So, that, those kind of issues shift responsibility most likely on the data users, those having access to the data, analyzing the data, and putting information out. And that's certainly another paradigm shift to think about. In terms of the statistical framework to think about, and also discussed in this book that we mentioned, but briefly in the AAPOR task force report as well, the role of statisticians, access to data, and analyzing data is changing. But there's still an important role here, because we still are concerned about making valid inference. Right? What's certainly inadequate are current solution to statistical disclosure. We have limitations in the tools that we've been using currently, and it is worthwhile looking into new analytic frameworks developed to overcome this problem. Most prominently, or very interesting, sort of the idea of measurement of privacy loss and issues of differential privacy. Now, we won't have time in this webinar to go over all of this in detail. So again, I refer you to the book or the task force report, or if you want to dig deeper, check out the references that we give in the report and look for the keyword of differential privacy or Cynthia Dwork as an author of that. Certainly it's the case if you think of importance of statistical inference that we don't, or Julia Lane, and she gave the presentation for this portion of the Big Data Task Force report last April, reminding us of the Literary Digest disaster snafu, however you want to call it, way back when people thought, oh, just because we have a lot of data, we are safe to make good inference. If you want to hear more about that story in detail and sort of a new, fresh perspective on it, you might enjoy watching this YouTube video from Sharon Lohr that was recorded Friday, March 11 as part of the JPSM Distinguished Lecture Series. You can find it on YouTube if you Google for it, and she is talking about this very instance in the context of big data, and quite enjoyable talk. I can highly recommend that. Finally, there are some practical suggestions already on the table for this issue dealing with privacy that you might want to check out. There's a report from the National Research Council on proposed revisions to the Common Rule that those of you interested in ethics and privacy should definitely check out. There's some recommendations on the data protection itself, and also recommendations on sort of minimizing risk and expediting reviews. There's a limit to the amount of information that can be processed in one of these audio recordings, so I will leave this for you to read and refer back to this very interesting other resource. So finally, moving on to skills. So what are the tasks required to get there and using these data sources, right? So we've got hooked to the idea it can be useful. Lots of data out there. They are cheap if you only know how to use them. They can be accessed quite easily. Still issues of privacy to be solved, as we discussed, but again, you need to know then what to do with them and how. And for that, AAPOR developed this nice graph as part of the task force report, laying out or highlighting with it that this is really a team effort, right? So we have computer scientists, we have system administration people, we have domain experts, and researchers/methodologists. All of them really needed and working tightly together in order to make sense of these data. If you don't have the domain expert, you will never get good understanding on the process that is really generating these data, and thus won't easily understand flaws that might be there. But it might take a survey methodologist or a statistician to probe the domain expert to find these error sources that we discussed earlier. Likewise, you might need a team of skilled computer scientists who can handle the data processing part, and system administrators to just provide to you the infrastructure to handle these data. So, we discussed what is big data, but then aside from the big data, big word, there are other keywords that you might have seen that often come up in this combination of in this discussion of big data, and one of them is, Hadoop file systems and MapReduce. And AAPOR has put together the slide deck for last AAPOR, basically highlighting these two people, computer scientists and system administrators that we saw earlier in the jigsaw puzzle piece, and the skills that they would bring to the table. From a computer scientist, you will get, skill sets that are related to data preparation, to the MapReduce algorithm, which is basically a way to allow for distributed computing. So you will, instead of performing all the computation on one single machine, you map the task out to different machines and then combine the results back together. A lot of this can easily be done with Python, which is a low-level programming language. Actually quite easy to learn, certainly easier than German, I can tell you that. But also, if you learned R, if you learned SAS, if you learned SPSS, and not just the point-and-click version of the latter two, or Stata for that matter, but actually wrote code, you will find it quite easy to learn Python. It's a very logical language, but also a lot of the things that need to be done there don't necessarily require Python. That is a language of choice among the computer scientists, but many of the things being done can be done with ARM. And then on the system administrator side, so that you're looking at just how to handle the sheer volume of these data, right? So you might store them in database systems. MySQL is a keyword in this context. You might use storage facilities and that are outside your own agency. And interestingly enough, there are a lot of very cheap or even free services to store data, and to the extent that there's no privacy issue, you could certainly make use of them. Amazon Web Services are just one example. We list a couple of more in the AAPOR Task Force report. And they employ this, or often they employ this Hadoop ecosystem, which, if you puzzle over what is this word Hadoop really mean, and does it stand for something? Well, it actually just stands for this tiny little elephant, which was the toy of the kid from the developer at that time. So, these are big words, but they shouldn't frighten you. It's just, an infrastructure that happens to have different names attached to it, but certainly nothing beyond what you could learn if you decide to sink your teeth into it. But you might not have to, because, as I said, likely your skills that you already have are very much needed to get a good project running, and it might be the best approach to actually have a team of people, specialists in each of these areas, work together. Now, if you do want to pick up some skills, there are recent educational initiatives that I mentioned, and that are worthwhile mentioning and paying attention to. I'm sure more of them will bubble up in the future. Local to the DC area, and that's why I'm familiar with it, an effort that Julia Lane initiated together with the leadership of the U.S. Census Bureau, with the course entitled Big Data for Federal Agencies. And you might even recognize some of the participants in the last installment of this class that I did together with Julia Lane when we ran the class through JPSM. So, here in this course, the idea was to basically take economists, survey researchers, social scientists from the federal agencies and sort of familiarize them enough with the language of, these other tools and sets of skills that might otherwise be more familiar to computer scientists. Show them how to do some easy web scraping. Most importantly, introduce them to database management systems. A very efficient way to deal with data, and certainly something that we should keep in mind and learn more about as we deal with many different data sources of different types. Some brief introduction to text mining and machine learning, a better understanding of networks. I mentioned earlier, networks are sort of new units of analyses, not entirely new to social scientists, but now much better data on networks, and therefore, in a sense, a unit of analysis that can be much more easily paid attention to than in the past. Data linkage, mentioned that the real value comes through linking these data together, so that's a skill that's certainly worthwhile to pick up. But then also issues of statistical inference, as we discussed, those are that shouldn't be forgotten. And finally, visualization pieces, being able to convey the information, which, in the various granularities, visualization often allows zooming in ways that tables often don't. Another educational initiative that I do want to mention is, sort of the opposite of local, a global initiative that we started at the joint program in civil methodology together with colleagues from the University of Mannheim. The idea of building on existing programs and offering a quite modular program geared towards working professionals that allows students to take, or I guess working professionals, to take courses in each of these layers that are necessary to be successful dealing with these new worlds, right? Courses that relate to the data generating process, courses that relate to data curation and storage, to data analysis, and to output and access. And, but this, as I said, is very much still in the development phase. So, be in touch if you want to know more about this, or if you have any other questions on the report. I would be happy to answer this or point you to one of my fellow task force members who can probably answer all of these questions even better than I can. Thank you very much.